Okay, today we're going to continue our discussion in algebra on the topic of exponents and order of operations. So let's dive right into it and start talking about exponents. Take a look at something like this, 4 to the power of 2. This is also known as 4 squared. And basically the only thing you have to know to decode how to do this thing is the number on the top indicates how many times I multiply the bottom number together. So just going through a few quick examples, 4 squared is simply 4 times 4. 4 to the third is 4 times 4 times 4. 59 to the fourth is 59 times 59. Whoops. 59 times 59 times 59. All this is a shorthand way of compacting this down. We just write 4 squared, and it's 4 times 4. 4 to the third is 4 times 4 times 4. Make sure that you do not say that this is equal to 4 times 2. This is not equal to one another. And to see that, let's go ahead and just do that real fast. So we'll erase these other examples and proceed. 4 times 4 is 16. 4 times 2 is 8. And you can see that those are definitely not equal to each other. So this is simply a shorthand way of writing 4 times 4. Do not get in the habit of thinking it's 4 times 2. You may have to force yourself to think twice, but make sure that it's that way. And some people may say, well, who cares about writing it like this? I'll just write it out all the time. Well, we'll see pretty soon that you're not going to be able to do that. The equations will get just massive unless you start to write it in exponential form. Okay, let's take another example. Something a little different, but very similar. 6 squared. Okay, that is simply equal to 6 times 6, which is equal to 36. So it's very simple as long as you know how to do it. Let's do something a little different this time. 1 over 10 to the fourth. It's a fraction, right? And you're like, oh my goodness, what do I do with that? Well, you just write it out. You've got 1 over 10 times 1 over 10 times 1 over 10 times 1 over 10. Okay? Whatever's inside the parentheses, notice that the entire body of whatever you've written inside the parentheses, the entire thing is raised to the fourth power. So whatever is in here is multiplied 4 times. And so we've introduced the parentheses here. All you do is you treat whatever's inside there as a complete unit, as a single thing that you can't break it apart, and you multiply it together. So what is this equal to over here? 1 times 1 times 1 times 1 is 1. Remember, we multiply the top of fractions, we multiply the bottom of fractions. 10 times 10 times 10 times 10, you do that in your calculator, you'll write that as 10,000. Okay? That's the answer. Now, one quick short way of doing this, you can write this all out, no problem, but I'll tell you another thing about fractions. When you're raising fractions to a power like this, all you need to do, you can raise the top part of the fraction independently of the bottom. So you can also write this as 1 to the fourth power over 10 to the fourth power. And you just know that 1 to the fourth is 1 times 1 times 1 times 1. That's 1. 10 to the fourth is 10 times 10 times 10 times 10. So you get the same thing, 10,000. Now, really, we've done exactly the same thing. Nothing is even really different here. It's just in one case we've explicitly written all the fractions out and multiplied them. The other, I can just tell you that you can raise the top to the fourth power and the bottom to the fourth power, and you don't really have to expand all of it out explicitly unless you just really want to. Okay. Okay. Let's do another example of how to deal with fractions and exponents, and then we'll be on our way. Like I say, the important thing with fractions, raising them with exponents, is just make sure that you do the top and the bottom. You can raise the top and the bottom of the fraction independently. You just keep your fraction bar there, and that's what's easy about fractions. Fractions really aren't that difficult. Honestly, adding and subtracting fractions are a little bit more difficult than multiplying them or raising them to a power. So let's do another one. 1/2 to the 6th power. Now, I could write this out. I could say 1/2 times 1/2 times 1/2 times 1/2 times 1/2 times 1/2 6 times, and I can multiply all that out, and I get the answer. Let's do it a slightly different way. This is an example of why it's useful. I can write this as 1 to the 6th power. I can raise the top to the 6th power, and 2 to the 6th power. I can raise the bottom to the 6th power. You just stick this exponent inside in both places and keep the fraction, and then do it like this. 1 to the anything power is always going to be 1 because I'm just multiplying 1 times 1 times 1 times 1, etc. So that's a big fat 1. And 2 to the 6th power, you've got essentially 2 times 2 times 2 times 2 times 2 times 2, 1, 2, 3, 4, 5, 6, right? And if you forget to do how to do this, I mean, you could just plop it in your calculator. 2 times 2 is 4. Okay, 2 times 2 is 4, and 2 times 2 is 4, and all these are multiplied together. And you could do it like that and multiply that out. Another way of doing it is to note that 2 times 2 times 2 is 8. 2 times 2 times 2 is 8. 8 times 8 is 64. So you can write this as 64 under here. Or you could use a calculator if the teacher's letting you do that. And notice that, in that case, we're raising it to the 6th power. So that's really useful to compact it down. Okay, next thing we're going to learn about is factors. We're going to write these products. I'm going to write something on the board here, and we're going to write it as a product of several factors. A factor is basically something that you multiply together to equal something. So the factors of x squared are simply x times x. Well, we know this because x squared is x times x. We only do it 2 times because it's a square. And in this case, the factors of this term, this is called a term, the factors are simply x and x. And the product of these factors give me x squared. So that's pretty simple. You'll get the idea here in a second. 3z to the 4th. All of the factors that make up this guy, if we write all the factors out, are 3 times z times z times z times z. So if they ask you to write the product of the factors, all you've got to do is expand the thing out. You've got a 3 there, multiplied by z to the 4th. Z to the 4th is simply represented as z times z times z times z. So this is actually equivalent to that. They're exactly the same thing, no difference. Okay, let's try 5t squared. Well, this is a little interesting. Notice that I have parentheses here, and the square is outside the parentheses. That means everything inside I have to raise to the 2 power. So it's the same thing as saying 5t times 5t. I've done this twice, and that's equal to 5t squared. Now, of course, this is an implied multiplication, 5 times t times 5 times t. So it's really all multiplied together there in the end. And then there's just one more simple one. 5 parentheses 2x parentheses to the 3rd. How do I write this? Well, this is simply 5 times 2x to the 3rd. I just put my multiplication sign in there. This is implied multiplication here. And the 3rd power only applies to the parentheses. It only applies to the parentheses here. It does not apply to the 5 in this case. Now if I want to expand this, I'm going to carry my 5 through, and I'm going to have 2x times 2x times 2x. And that's going to be the answer. These are all the factors involved in this term. 5, 2x, 2x, and 2x. And that's how you expand that out. And that's what this is really representing. Okay, let's move on. We're rapidly getting into the the fun part of algebra. This stuff is kind of tedious that we're doing now, where we're constantly simplifying terms. Eventually, we'll get to work some cool problems where we can actually use this stuff for something. But I promise you, it's all extremely useful. Okay, now the next thing I'm going to do is I'm going to write an expression on the board, and I'm going to tell you what x and y are equal to, and we're going to simplify the value of that expression. So for everything that follows, x is equal to 3, and y is equal to 2. So let's just box that. We're not going to erase that. That stays there. Okay. Remember, x and y are numbers. In this case, I've just told you what the numbers are. And all the other expressions, when we were writing them down, 3t to the 5th or whatever, I haven't told you anything about what t is. It's just a expression that I'm simplifying. In this case, I'm telling you explicitly what it is. So let's take a few expressions. 4x squared. I want to simplify that. It's already simplified as far as algebra goes, but now I know explicitly what x equals. So I'm going to simplify this. This is the same thing as 4 times 3 squared. All I did was take x, which is 3, plop it in x's place here, and keep everything else exactly the same. We already know how to do this from before. This is 4 times 3 times 3. 3 squared is 3 times 3. Right? And 3 times 3 is 9, so this term is 9. So 4 times 9 is 36, and that's the answer. So 4x squared, when x is equal to 3, is equal to 36. Okay? Let's take another one. 5y to 5y parentheses to the third. Now notice the difference between this and this. 4x squared, the square only applies to the x because there's nothing written as far as the parentheses go. Now when I put the parentheses around it, it looks almost the same, except now because there's parentheses, the cube applies to everything inside the parentheses. It applies to everything inside. So the easiest way to do this is just rewrite it and put y in the proper place. So inside the parentheses we have 5 times y. In this case y is 2. Put a 2 there. Close the parentheses and put a 3. Okay? Now again, carry the parentheses through. 5 times 2 is 10. Close the parentheses, put a 3. Now I'm left with 10 to the third, which is 10 times 10 times 10. Do it 3 times. 10 times 10 is 100. Times 10 is 1,000. So the answer is 1,000. Not that bad. You just have to keep track of the parentheses. Notice if you do this differently, and if you don't apply the cube to the entire thing inside, if you were to do it like this, you would get a totally different answer. So the parentheses is absolutely crucial. It's like speaking French versus speaking English. I mean, if you don't use the parentheses properly and know that you need to do the parentheses first, essentially, you're going to get the wrong answer. Another way to think about it is just always evaluate what's inside the parentheses first. You basically, order of operations, you always want to evaluate the parentheses first, and then everything else comes after that. We'll talk a little bit more explicitly about it in a minute. So let's take another real fast. 2x to the y. Okay. Notice there's no parentheses here. This looks different, right? I've got letters in both places. That's okay. No big deal. It's like a jigsaw puzzle. I just put it in place. Carry the 2 times x, which is 3, raised to the y power, which is 2. Now it's just simply numbers. Okay. Now here's an interesting thing. What do you do first? Do you multiply 2 times 3 and then raise it to the 2 power? Or do you take 3 and raise it to the 2 power and then multiply it by 2? You always do exponents first. Okay, so you take 2 times and then 3 raised to the 2 power. 3 times 3 is 9. So that goes there, and then 9 times 2 is 18. Okay, that's the answer there. Alright, and we've got room for one more, I think. So let's take 3y raised to the x power. Again, plug it in. carry the parentheses, 3 times y, which is 2, raised to the x, which is 3. 3 times 2, we always do the inside of the parentheses first. 3 times 2 is 6, raised to the 3 power. And you can do that in your calculator. This is just going to be 6 times 6 times 6. Well, 6 times 6 is 36. 36 times 6. And if you do that in your calculator, you'll see that that's equal to 216. Alright, let's erase this. And then we'll be moving on to even more interesting things in this topic. We're going to do this part of the class so far today has been dealing more with exponents. Notice all the problems that we've done so far have been involving heavily exponents. Now we're going to start introducing multiplication, division, exponents, all in the same kind of problem. And you need to take some time to study and be aware which parts of the thing do you simplify first. Which parts of the problem do you simplify first? So that's what we're going to be doing next.